Hello everyone, I'm Ms. Nilanjana Ghosh of Azan Benke's International School. Today's lesson is for MOE Bilingual Grade 12 Chemistry. Topic: pH of strong acid and weak acid. Chapter 8: Quantitative Equilibria. The learning objective for today's lesson is 8.1g. Calculate the values of H plus and OH minus ions of strong acid and weak acid. What is pH? The acidity and alkalinity of a solution is often measured by its pH. pH has a formula. pH is equal to minus log to the base 10 H plus ions. And H plus ions can be calculated using the formula H plus ions is equal to 10 to the power minus pH moles per decimeter cube. To calculate OH minus ions, we need to use the formula of ionic product, which is Kw is equal to H plus ions times OH minus ions. So OH minus ions is equal to Kw divided by H plus ions, which is equal to 1 into 10 to the power minus 14 divided by the concentration of H plus ions. To find the pH of strong acids, we need to use all three formulas, that is pH, formula of pH, formula of H plus ions, and formula of OH minus ions. pH of strong acids. Example 1. Calculate the pH of 0.20 moles per decimeter cube of HCl. HCl is a strong acid, so it dissociates completely to form H plus ions and Cl minus ions. The initial concentration of HCl is 0.02 moles per decimeter cube. So the concentration of H plus ions formed also will be 0.02 moles per decimeter cube. Using the formula of pH, pH is equal to minus log 10 H plus ion concentration. Substituting the concentration of H plus ions into the formula, we get pH is equal to 1.70. Note, do not round off pH to a whole number. pH has no units. Example 2. What is the H plus ions and OH minus ions concentration of a solution of HCl of pH 2.30? HCl dissociates complete to form H plus and Cl minus ions. pH given in the data is 2.30. So the concentration of H plus ions is equal to 10 to the power minus pH, which is equal to 10 to the power minus 2.30 is equal to 5.01 into 10 to the power minus 3 moles per decimeter cube. To find the concentration of OH minus ions, we use a formula Kw divided by the concentration of H plus ions. We substitute the concentration of H plus ions from the previous section and we get the answer of 2 into 10 to the power minus 12 moles per decimeter cube. Let us consider sulfuric acid. Sulfuric acid has two protons. When it dissociates in two steps. In first step, sulfuric acid dissociates to form H plus ions and HSO4 minus ions. In the second step, HSO4 minus dissociates to form H plus and SO4 minus. The Ka value for the first step is very large, whereas the Ka value for the second step is low. So we can ignore the second ionization and treat H2SO4 as a monoprotic acid. The word monoprotic means it has only one proton. Let's discuss a question. The pH of 0.1 moles per decimeter cube of sulfuric acid is 0.98. Calculate the concentration of hydrogen ions in the solution. pH given is 0.98. Using the formula of concentration of hydrogen ions equal to 10 to the power minus pH, substituting the value of pH in the formula, we get the concentration of hydrogen ion equal to 0.105 moles per decimeter cube. Part 2. Suggest why the concentration is not 0.2 moles per decimeter cube in 0.10 moles per decimeter cube of sulfuric acid. The reason is the second ionization of sulfuric acid is very low compared to the first ionization, so it is ignored. So sulfuric acid is taken as a monoprotic acid. pH of weak acid. Let us recall the definition of a weak acid. A weak acid is one which only dissociates partially in water. Let us take a weak acid HA. HA dissociates partially to form H plus ions and A minus ions. The acid dissociation constant Ka is equal to the concentration of the products divided by the concentration of the reactants, which is given equal to concentration of H plus ions times concentration of A minus ions divided by the concentration of HA. Now, we also know that the concentration of H plus ions formed in a weak acid is not same as the initial concentration of the acid because the dissociation is only partial. So, the formula of H plus ions formed in a weak acid is given by H plus ion concentration is equal to square root of Ka times the concentration of HA. To arrive at this formula, there were two assumptions made. The first one is the concentration of H plus ion is assumed to be equal to the concentration of A minus ions. And the second assumption is the concentration of HA at equilibrium is equal to the initial concentration of the acid. Along with this formula, we will be needing some other formulas. The first one is pKa is equal to minus log 10 Ka and Ka is equal to 10 to the power minus pKa. pH is equal to minus log 10 H plus. Example 1. Calculate the pH of 0.1 moles per decimeter cube solution of ethanoic acid at 298 Kelvin given Ka is equal to 1.7 into 10 to the power minus 5 moles per decimeter cube. The concentration of ethanoic acid given is 0.1 and Ka is equal to 1.7 into 10 to the power minus 5. Using the formula of H plus ions in a weak acid, H plus ion is equal to square root of Ka times the concentration of the weak acid. Substituting the value of Ka and concentration of ethanoic acid in the formula, we get H plus ion is equal to 1.3 into 10 to the power minus 3 moles per decimeter cube. Now, using the formula pH is equal to minus log 10 H plus, substituting the value of H plus ions in the formula, we get pH is equal to minus log 10, 1.3 into 10 to the power minus 3. So the pH is equal to 2.8. Example 2. Calculate the pH of 0.12 moles per decimeter cube of HX, which has a pKa equal to 5.64. pKa given is 5.64. Using the formula Ka is equal to 10 to the power minus pKa, substituting the value of pKa in the formula, we get Ka is equal to 2.29 into 10 to the power minus 6 moles per decimeter cube. To find the concentration of H plus ion, we know HX is a weak acid because it has a low Ka, So we use the formula of H plus ions in case of a weak acid, which is equal to square root of Ka times concentration of Ha. Substituting the value of Ka and concentration of Ha in the formula, we get H plus is equal to 5.24 into 10 to the minus 4 moles per decimeter cube. To calculate pH, we use the formula pH is equal to minus log H plus. Substituting the value of H plus obtained, we get pH is equal to 3.28. Example 3. Calculate Ka and pKa for weak acid Ha, which has a pH of 4 at 1.2 into 10 to the power minus 3 moles per decimeter cube concentration. pH of A provided is 4 and the concentration of Ha provided is 1.2 into 10 to the power minus 3. Using the formula, H plus is equal to 10 to the power minus pH. Substituting the value of pH, we get H plus is equal to 1.0 into 10 to the power minus 4 moles per decimeter cube. Now, the concentration of H plus ion is equal to the concentration of A minus. So, Ka is equal to H plus times A minus concentration divided by the concentration of Ha, which is equal to 1.0 to 10 to the power minus 4 squared divided by 1.2 to 10 to the power minus 3, which is equal to 8.33 into 10 to the power minus 6 moles per decimeter cube. Let us discuss some exam style question. Question 1. The following table shows the pH values of 4 different solutions, each with same concentration. Consider the table and answer the questions below. There are 4 solutions: vinegar, baking soda, ammonia, and vitamin C. The pH value are: vinegar has a pH value of 3, baking soda has 8, ammonia has 12, and vitamin C has 4. What is the reaction between vinegar and ammonia called? From the table we see vinegar has a pH 3, which means it is an acid, and ammonia has a pH 12, which means it is a base. So a reaction between an acid and a base is called neutralization. Which solution has the highest tendency to donate protons? From the definition of acid, we know acids are substances that donate proton easily. From the table, there are 2 acids. One is vinegar and the other is vitamin C. Now, between vinegar and vitamin C, the lowest value of pH is of vinegar, which shows that it is a stronger acid compared to vitamin C. So, the answer is vinegar. Calculate the concentrations of hydrogen ions in ammonia solution. The pH of ammonia from the table is 12. So the hydrogen ion concentration is equal to 10 to the power minus pH, which is equal to 10 to the power minus 12 equal to 1 into 10 to the power minus 12 moles per decimeter cube. Arrange the solution in the above table according to the concentration of hydroxide ions from least to highest. Now, from the table, we see there are 2 acids. One is vinegar and the other is vitamin C. Ammonia has the highest pH, which means it has the highest concentration of hydroxide ion. After that is baking soda, which has a pH 8. The lowest hydroxide ion concentration is of vinegar, which has the lowest pH. So the order is vinegar, followed by vitamin C, baking soda, and ammonia. Question 2. Methanoic acid, ethanoic acid, and iodic acid HIO are all weak acids. Iodic acid has a pKa of 10.64. Complete the table by calculating the value of Ka for iodic acid. pKa given is 10.64. Using the formula Ka is equal to 10 to the power minus pKa, substituting the value of pKa in the formula, we get Ka is equal to 2.29 into 10 to the power minus 11 moles per decimeter cube. Write the expression for Ka for methanoic acid, which has the formula HCOOH. Methanoic acid is a weak acid, so it dissociates partially to form H plus ions and HCOO minus ions. So the Ka expression is given by concentration of the products divided by concentration of the reactants, which is equal to concentration of H plus ions times concentration of HCOO minus divided by concentration of HCOOH. Calculate the pH of a solution of methanoic acid with a concentration of 0.50 moles per decimeter cube at 298 Kelvin. Methanoic acid is a weak acid, so we use the formula of H plus for a weak acid is equal to square root of Ka times the concentration of the weak acid, which gives us 8.94 into 10 to the power minus 3 moles per decimeter cube. To find the pH, we use the formula pH is equal to minus log of H plus. Substituting the value of H plus from the previous equation, pH is equal to 2.05. Write an equation showing the products of the equilibrium which is set up when iodic acid is mixed with ethanoic acid. Now both iodic acid and methanoic acid are weak acid. When two weak acid reacts, one acid acts as an acid and the other one acts as a base. Now, the one which is a stronger acid will act as an acid and the weaker acid will act as a base. From the table we see ethanoic acid has a Ka value of 1.7 to 10 to the power minus 5, whereas the iodic acid has a Ka value of 2.29 into 10 to the power minus 11. So ethanoic acid is a stronger acid and iodic acid is a weaker acid. So iodic acid will behave as a base and accept a proton from ethanoic acid. So we get H2IO plus CH3COO minus. Thank you.